On the 1st of June 2009, Air France Flight 447 was crossing the Atlantic Ocean from Rio de Janeiro to Paris. Carrying 228 passengers and crew, it was one of thousands of routine flights taking place around the world that day. But over the Atlantic, something went terribly wrong. Search teams quickly discovered debris floating on the surface, but finding the wreckage was only the beginning. Investigators still had no idea what had caused the aircraft to crash. The crash site lay almost 4,000 meters below the surface. It would take investigators nearly 2 years to locate the wreckage scattered across the ocean floor. Among the debris, investigators discovered the aircraft's flight recorders, 2 small orange devices that had somehow survived nearly 2 years on the ocean floor. The aircraft had been torn apart, yet the data survived. In fact, the information stored inside these recorders would eventually reveal exactly what happened to Flight 447, which raises an incredible engineering question. How can a 70-ton airliner be destroyed while a device no larger than a shoebox survives? Despite the name, black boxes aren't actually black. They're painted bright orange to make them easier to find amongst wreckage, debris, or even on the ocean floor. The first recorder is called the Flight Data Recorder, or FDR. It continuously records hundreds of aircraft parameters, including altitude, speed, engine performance, and control inputs, creating a detailed record of the flight. The second recorder is the Cockpit Voice Recorder. It captures pilot conversations, radio communications, and important sounds inside the cockpit during the flight. Together, these 2 devices allow investigators to reconstruct exactly what happened before an accident. They transform mystery into evidence, and evidence into answers. Designing an aircraft is difficult enough, but designing a device that can survive when the aircraft itself is destroyed presents an entirely different challenge. The most important part of the recorder is surprisingly small. Deep inside sits the memory unit containing all of the flight's critical data. Everything else exists to protect it. Surrounding the memory unit is a thick protective shell made from titanium or stainless steel. These materials are chosen because they can absorb enormous forces without failing. The memory unit isn't protected by a single barrier. It's surrounded by multiple layers of insulation, shock protection, and structural armor designed to work together. To prove it can survive a crash, every recorder must pass extreme impact tests. These simulate forces of thousands of times the force of gravity, conditions that would instantly destroy most electronics. While aircraft are designed to fly efficiently, black boxes are designed for one purpose above all else: survival. Their only job is to ensure the data lives on, even when everything around them is destroyed. Many aircraft accidents are followed by intense fires that can burn for hours, exposing the recorder to temperatures that would destroy ordinary electronics in seconds. To survive these temperatures, the memory unit is surrounded by specialized thermal insulation. This protective layer acts like a shield, slowing the transfer of heat and keeping the critical electronics safe inside. Before being certified, flight recorders must survive extreme fire tests. They are exposed to temperatures of around 1100 degrees Celsius, hot enough to weaken steel and destroy most electronic devices. If the crash occurs over water, another challenge begins. The recorder may spend months or even years deep beneath the ocean's surface under enormous pressure. To prevent water damage, the recorder is built with multiple seals and protective barriers. Even under immense pressure, water must never reach the memory unit inside. Air France Flight 447 provided a remarkable demonstration of this engineering. After spending nearly 2 years on the Atlantic seabed, the recorders were recovered and investigators were still able to retrieve the data stored inside. Surviving the crash is only useful if investigators can find the recorder. That's why every flight recorder is equipped with an underwater locator beacon that activates automatically when submerged. The beacon emits an ultrasonic ping that helps search teams narrow down its location. In ideal conditions, these signals can be detected from several kilometers away. Once recovered, specialists extract the information stored inside. Every second of flight data and every cockpit conversation becomes part of the investigation. In the case of Air France Flight 447, the recovered recorders revealed the sequence of events that led to the crash. Without that data, investigators may never have fully understood what happened. When an aircraft crashes, almost everything can be destroyed. But one small device is designed for a single purpose: to survive long enough to tell the story. And because of that, countless aviation mysteries have been solved and future accidents prevented.